All right, so do you want me to just roll on through?
Yes.
Yes? Okay, so number 40, some of you were dead in the water right off the bat because you did the wrong thing when you were asked to enter stuff into L1 and L2. The directions say, produce a scatter plot of the number of children homeschooled in thousands. So they don't want all those zeros on the end. And as a function of years since 1990. So they don't want you to type 1992, they don't even want you to type 92, they want you to type 2, 3, 4, 5, 6,
Yeah, well, I know
7.
myself.
Now if you did it with 1992 and you did it with all of the numbers, your predictions should still come out the same, but your equation is going to look considerably different than what the book came up with.
Okay, so and then we would do the one that says to predict what will be 2005 and put 15.
Yes, that's correct. Because 2005 is 15 years from 1990. Okay, so you got all your stuff in L1 and L2. It says produce a scatter plot. So we did this yesterday. So you make sure, Justine, that your plot is on. You go zoom 9, and there's your scatter plot. Okay? What does that look like? What kind of a function would best model that data? Linear. Okay, so it says find the linear regression equation. So Taylor asked, is there a way to get the equation to go right into y1 instead of you having to copy it down? And the answer is yes. I didn't want to do too much at one time yesterday, so I didn't show you that, but it's really pretty simple. When you get this up here on your screen, before you hit enter, if you go alpha F4 Y1 and now hit enter, then not only will the regression equation come up on your screen, but now it's also pasted into the Y1 spot. Okay, so that means on your graph, the line is already graphed for you. Okay. Now, Ashley and some other people that have the fancy ones that you have to go down to calculate, there's a line right above calculate that says, I don't know what, something, but that's, if you type L or Y1 in there, then it'll do the same thing. Okay? Anyway, so here is the regression equation. And so you want to round this a little bit. The book has one thing, it says round to the nearest point, 0.1. So y equals 131.06x plus 421.41, and that's your equation. All right, then it says, does the value of r squared suggest that the linear model is appropriate? How many of you do not have this r squared thingy on your screen?
I don't think mine does that.
You don't have it? Okay, I will show you how to get it. Are you ready?
Oh, yeah.
Okay.
No. Yes.
Okay, so second catalog, which is 0.
Wait, oh.
This is if we don't have all
If you
the
don't have the r and the r squared values coming up, then you need to turn it on. So go second, 0. And this gives you a catalog of all of the different things that your calculator can do. We want to turn our diagnostics on. So you can scroll all the way down to the D's. But if you don't want to do that, you can push the X to the -1 button, which has a D above it, and that'll jump you down to the D's automatically. Hold on just a second. Okay,
Mine
bye.
doesn't do that.
Doesn't matter. One way or the other, get down here until it says diagnostic off and diagnostic on.
Mine doesn't even have that.
Okay? Oh, yes, it does. And then, what? I don't know what it is yet.
You have to scroll
get it
down
from one
past
of
the
your-
X's.
Fellas,
What is it?
then if you hit enter, so that this goes into the home screen, what?
On what one?
Diagnostic on. Then you have to, the weird thing is you have to hit enter again until it says done. And now when you do your regression thing, you should get an R and an R squared. Get it going there. Okay, these are statistical measures of the accuracy of your function that you came up with. And the closer these are to 1, the more accurate your model is. So if it's 100% accurate, if it hits every line exact, or every point exactly, then these would both be 1, okay? Now, if you look at this graph, it doesn't hit every point exactly, but it's pretty dang close, right? So that's why the R value is so close to 1. So it's 0.99 something, so that means that is the linear model appropriate? Yes. Okay, so it seems to be a good, well, what's the R squared? We don't want to give, it's a statistics thing. It's crazy. There's R, there's R, there's
When do we take statistics?
college.
It'll be like.
Okay, so D says now find the quadratic regression equation. And so we're going to do the same thing. We're going to go stat, calc. This time we're going to go 5. And if you want to paste this into Y2 instead of Y1, you can do that. You just have to go alpha F4 and now choose Y2 instead. And then hit enter.
Okay, hold on.
Holding on.
I put alpha F4 and little thing came up with the graph.
Because you don't have the new operating system.
D.
So you have to get the Y1 and Y2 the long way. Would you like me to show you what that is?
No.
What?
Can you
But
replace
then
this?
you laugh, so
Can-
it is counting.
If a screen goes dead in one of these, can you replace them somehow?
If the, like, the pixels are bad or whatever.
Because my screen went like dead, like half of it works and half of it doesn't.
Yeah, if you get on the website, it's called TI Cares.
Huh?
Then I think you can send in your
Oh,
calculator and
let
they'll
me do-
send you a new one. I don't know, something like that. Yes, okay, we'll work on that in just a
Send
second.
it in TI carries with the name.
When do you graduate? Because when you get back from that all-night party, I'm gonna be waiting for you to
That
fight.
is gross.
Okay? Yeah, so have a good shot at it. You won't know what's going on. Okay, so D says find the quadratic regression equation, round the coefficients to the nearest 0.01. So this would be y equals 4.75x squared plus 88.31x plus 503.74. Okay? And then E says, does the value of r squared suggest that the quadratic model is appropriate? So if you look at the r squared, yeah, that looks pretty good. So how do we know? And if you look at the graph, which everyone except for Ashley can do, there's the linear one, and there's the quadratic one. And so what they have is they have like a really, really wide parabola. You can see just a little bit of a curve in there, but that one's pretty close to the points as well. So the way we're going to test to see which model we think is the best is we're going to use them to make a prediction, and then we're going to see which prediction sort of seems like it would make sense, okay? So they want us to use both models to predict the number of kids that are homeschooled in the year 2005. And Tucker points out that since they want us to go from the year 1990, what do we plug in for X? 15. So the year 2005 means X equals 15. So the first thing you have to do is plug 15 into this one. And I'm sure someone will tell me in a second what that works out to be. 2,000.
387.31.
Okay, and so since we did to the nearest 1,000, that means 2,387,310 kids homeschooled. Okay? How about if you plug it into the other one, the quadratic? Did anybody get that answer? What? 2,000 what, what, and what?
897.14.
0.14? Okay, so those are your two different things. How different are the estimates about? They're off by about 500,000, which is a significant number of kids, okay? So obviously when things start, going farther and farther away, you would have to make a decision about whether you were going to use linear regression or quadratic. And so that's what part G is all about. It says use the results of this exploration to explain why it's risky to use regression equations to predict predict y values for x values that are not very close to the data point. So why is it risky to take this and use it for something far away in the future?
Yeah. Like
Not accurate. Okay? So you're supposed to learn something from that as humans, as citizens of the world. When they say things like, so-and-so, such and such is going to happen in the year 2065, it's a long ways away. A lot of stuff can happen between now and then, and the models that they're using are not necessarily going to work, okay? So both of these models would be very accurate for making predictions close to these points, but 15 years away, who knows? Okay? All right, do I need to do the other one too?
Yes, please.
Yes! And was that 41?
Yes, sir.
What?
Like a lot of people are gone.
There are a lot of people gone.
Where is it?
I asked you where the short people are and nobody answered me. What? True.
It seems like they're just in the
But
middle.
we're such a
though.
close family that even losing those few people
Is there-
feel
I
like.
wish our
yeah.
class was as small as
But
last
Bobby's
year.
back.
Huh?
We had a huge class.
I thought it was close.
Okay, 41, Newton's law of cooling.
The window's gone, so he turned it on.
Dude, where were you?
Very nice. Just talking about family, you just tell them to shut up. You're that kid with family, huh? All right, so we're gonna start again.
Metaphorically.
So clear this stuff out of here.
Okay.
What? Do I want to erase yours? Oh, yeah, I do want to fix it. And then you're going to put the times in L1 and the temperatures into L2. You have everything entered into L1 and L2, right? And then it says make a scatter plot of the data. And so you have to go, well, first I'm going to clear out from Y1 the stuff from the last problem. And then I'm going to go zoom 9 again, and there's the scatter plot.
Wait, what's
Yes.
the long way?
How come all of you guys are boxes?
It depends on how you have it set up. So if you go second Y equals, and you go to your stat plot thing, just like we were talking to Evan yesterday about you can have a scatter plot or a line plot or a bar graph or
Yeah.
whatever. There's also 3 different kinds of marks that you can use for your graph. And you have apparently the little ones highlighted, so that's what you get, okay? Becca?
I got 1 dot on
You,
my.
okay.
Like-
You have
Oh, you're on
a
the
problem. Okay, I'll come talk to you in a
Zoom
second.
9.
Alright,
Yeah.
how do I?
Zoom 9.
I did that twice.
Okay.
I'm doing Zoom 9.
Okay.
Zoom 9. And it's to the graph. It's on the graph.
Thanks, Con.
Okay.
Because we're supposed to be on the graph.
Yeah, so that's the graph. Does this look linear?
Somewhat.
Not
Sure.
really.
Yeah.
Not really. It's curving just a little bit, okay? So this is not necessarily going to be a linear function. So now we're going to do something fancy. For part B, it says store L2 minus 72 in list L3. So we'll go stat, edit, and then over here to L3, we have to go, can I do this from the top? Let me try this for a second. What does it say? L2 minus 72?
Supposed to be 85 degrees.
Today it is?
Yeah.
Whoops.
It's short.
Those are
First
mine.
one, okay.
Yeah. Where's the L?
Oh my gosh.
L2 minus 72.
Sometimes they start at 5. No, they start at 6.
But why did you
Wait,
L1?
and can you enter that for all of them really fast? It's not working. Probably 5.
Okay, so what you need to do is you need to go over to L3, okay? And you need to go all the way up to the top so that the L3 is highlighted.
Yep.
All right? And that's where you're going to type in L2 minus 72. So the L2 is above the 2. And since it's blue, that means you hit the blue second button to access that.
Got
And
it.
then minus 72, and then enter. And what that does is it automatically subtracts 72 from all of these numbers right there. So now your L2 and L3 are the same, except the numbers in L2 are 72 bigger. And the reason why they did that is because if you look at the function that they give you at the very beginning Newton's law of cooling.
No.
It says the temperature equals 190, because that was the starting temperature, minus 72 times b to the t plus 72. So they're getting rid of some of that stuff, okay? All right, so now we're going to find the exponential regression equation. So they want us to do exponential regression, and we want to do L3 as a function of L1. So this is going to be weird, wild, and fun. So go back to the home screen, hit the Stat button, go over to Calc, and we want exponential. So go all the way down until you see EXP. I don't remember what number it is.
0.
0, okay, hit enter, but do not hit enter again, okay, because we want to do L1 versus L3 in this case. So that means I have to tell the calculator I want to go second L1, L1 is above the 1, so second 1, comma, and comma has its own button above the 7 button, and then I'm going to go second L3,
And then enter. Mine doesn't look like that. but I mean,
and then I'm going to go comma, and then I'm going to go Y1. So this will also get pasted automatically into my Y1.
Okay, now I think.
What's that? I got Y1 from Alpha Trace.
Does it
Wait,
like
up
store?
there.
Hold on.
Where's Trace?
Does that work?
Yeah.
Okay.
Can't find Trace.
What?
Do you have a,
Dragon and
where's Trace?
Yeah, I got different. Mine is totally different.
Okay, and then now if you hit, oh, I didn't hit enter.
I can't find Trace, Mr. Aldridge.
Oh, okay.
Mine's way different.
It's on the very, very top. Okay, so it comes up with a exponential regression equation, and then if you look at the graph,
You said alpha
there's
Trace,
something
right?
wacky going on.
Didn't you say alpha Trace?
Hold on. Yeah, Alpha Trace.
I
Just
clicked
relax.
alpha Trace.
Why? I don't know why they had subtract 72. Why is this way down here?
Because they moved it
Because
down.
the graph got shifted down 72. So I don't know why they had us do that. Okay.
So that was B.
So that was C.
I'm guessing
Oh,
Alpha
so
Trace
what
is on the
else is
new
this?
operating system, Mr. Aldridge.
What?
Alpha Trace is on the new operating system.
Yeah, and I can get you the new operating system.
Can you go back to like the new?
Just to let you know, you just ruined my whole thing.
No,
The
back
new
to-
new operating system.
Back to like the numbers.
Wow.